All right, so I do have Alan Toll. Alan, are you out there?
I'm here. Hi, Cisco.
Okay. How are you? Bill, I got Bill Madden. So as I speak with the various people, if you want to say hello and then just shut off your microphone. Warren, I still got your speaker on, so if you want to lower it. Bill Madden is out there. Bill, where are you from?
This is Bill Madden from St. Paul, Minnesota.
St. Paul, Minnesota. Uh, are you an architect or an engineer?
I'm an architect who's been here for approximately 30 years.
Perfect. Okay, we got caller in user 3. You want to identify yourself? No caller 3. I don't know who that is. We'll find out who that might be. Could be you, Warren. I've got Sean out there. Sean, you out there?
Yep, I'm here.
Yep.
Sean, this is Sean from Da Vinci Group.
Yep.
Perfect. You want to just identify yourself? What's your expertise?
Yeah, I'm a structural engineer working under Frank Vinciguerra at the Da Vinci Group in New Jersey.
Perfect. We got Sean Stoneberg on here also. Sean, you there?
Yep, I'm here. Yep.
And
Sean Stoneberg, I'm a structural engineer in Corvallis, Oregon.
There you go. Warren, you have somebody here that needs your attention? All right, so let me see who else I have out there. Do we have Gabe out there also?
Yes, sir. Greetings, everybody. My name is Gabe, National Fire Escape Association. I'm the Chief Technology Officer.
Perfect. All right, so we're recording, and the main focus of today's webinar, is going to be really on focusing on load testing, questions about load testing, and questions about welding associated with load testing, and bolts and repairs associated with load testing, and why by doing certain things you basically eliminate the load testing requirements. So let's in most states, some states still require the load testing even though you change all the hardware out there. So let's take a look at some of the concerns that we have in regards to, what's the biggest issue that we're having now. And the biggest issue primarily throughout the country is going to be really the use of a fire escape during an emergency event, primarily a fire. And a lot of people don't realize that fire escapes are made primarily first as a second means of egress for the occupants. That's the main reason why they were built. Once the occupants have safely left the building, because they leave the building by going out the front, or they leave the building by going out the back, get away from the fire, step away from everything, and then let the firemen do their job. The firemen show up, firemen start coming in the front of the building, firemen start coming in the back of the building, and the firemen do what they do best. And that's when they basically use the fire escape for ingress into the building. So what we have here is a situation that we're now 50, 75, 100 years out on a system that is in need of repair, in need of testing, and in need of a system that everybody can agree will protect the lives of the occupants in the building, but also protect the lives of the very firemen that come your way. So load testing. Two types of load testing that are going on as we speak now. Load testing in that, the fire escape gets used on a daily basis. Load testing. Fire escapes get used by tenants to get some fresh air. Load testing. And there's an event that occurs. And here you have 100 pounds per square foot load testing in action. This photo, as you can see, is pretty old. But as you can see, the fire escape is pretty packed. It's got firemen, it's got people, it's got smoke, it's got fire. But on a typical platform, if you can see here, let's take one of these typical platforms right here. If I can get my mouse on it, it's not showing right now. But if you look at the very top platform, and let's say that's a 5x5 platform, and you see firemen climbing up the stairs, firemen with hoses. 5 times 5 is 25 square feet. 25 square feet times 100 pounds per square foot. That means that these firemen that are on there can accumulate up to 2,500 pounds of weight on that, and that fire escape, if properly maintained and properly fabricated, properly installed, is going to hold the load. That is the maximum. But when you do some simple mathematics, you take these firemen. They all weigh 200 pounds apiece plus 100 pounds of gear. That's 300 pounds. You divide, 2,500 by 3. What do you get? It's 8 plus. So can you fit 8 firemen on a 5 by 5 square? The answer is going to be no. Now, if you take the same number, you divide by 150-pound average weight of a person, let's say, you're looking at maybe 15, 17 people. Can you fit 17 people, occupants in the building on a 5 by 5 square? The answer is no. So now the biggest issue that we have is, is the load testing an adequate number that basically exceeds the possibilities of what could ever get on these fire escapes? And so for an example, 8 firemen at 300 pounds, which you can never physically get on there, or we start making 500, 600, 700-pound firemen that basically are 10 feet tall, and can they fit inside that 5 by 5? The answer is yes. But currently we don't have any, 600-pound, 800-pound firemen that basically are 8 to 10 feet tall. So with that, we're looking at just some of the problems that we're having out there, where people are saying, what's the load test requirement? Why is it so high? Why is it so heavy? Well, it was basically made so that when we dealing with load testing, they went above and beyond the norm of what could ever happen to be on a fire escape. And this is a great dramatization of the possibilities of a fire escape that's fully loaded, fully engulfed, with tons of firemen, tenants, all on this fire escape. This fire escape is not coming down. So with that, let's continue on with what has been happening with fire escapes that has made people not rely on them like they used to rely on them 50, 75, 100 years ago, because that's when they were first built. They were in their first cycle of use in the first 25 to 50 years. But this is what occurred. I got some pictures here that everybody's going to be looking at of a typical fire escape that I removed from a school. And this here is an example and a dramatization of everything that could ever happen on a fire escape and the abuse it gets over 25, 50, 75 years, and the repair techniques that people have applied on them in the past 25, 50, 75 years. So with that, what's happening now is the credibility, the accountability of a fire escape to basically maintain its 100 pounds per square foot has been compromised. So let's take a few shots and a little bit of a look at some of the things that we have here. As you can see here in the lower corner, you can see that I tore this fire escape out of the asphalt. This fire escape came from the second floor down to the ground to a recess yard. It was buried in the dirt, and as you can see, it's very substantial. Somebody's speaker or microphone is echoing. So sometimes by shutting off your microphones, the echo stops, guys. So as you can see, the first concern that we have with this fire escape is that it was buried in the ground. The dirt ate the actual 8-inch C channel. In most cases, this is not repairable. There'd be some sistering going on in here if they want to keep the rest of the fire escape. If the engineer designed this and says, you know what, just replace 2 feet of it with another piece of steel of similar size. The biggest issue with replacement, somebody's microphone is still on, so somebody could check. Warren, you think your microphone is still on? Okay. So if everybody could just double check because you're getting some feedback loop through your own speaker and microphone system. So a lot of times when this is happening, what you want to do is you want to basically extend the C channel. I think we're going to have to get somebody to say hello and then shut off their microphone to identify whose microphone is left on the open position. Hello? Testing? Okay. So the one thing that's important here, let's go back one. The most important thing that goes on here is that any welding of any kind is not an acceptable means of repair. Whenever you have welding that occurs when somebody's fissering, you can splice existing steel in the same direction, but you cannot weld existing steel. You cannot weld existing steel that goes in the same direction, and that's just standard. Now we're going to be using some of the code that came out of New York City in the fabrication of fire escapes. It is welding is strictly forbidden on any activity when it comes to fabricating a fire escape. You can fabricate railings at the shop, so shop welding is allowed on bars and certain components of a fire escape, but you must field install using certain bolts. The minimum is 3/8, ½ inch, or 3/4, and it's all clearly spec'd out now in the code as early as 1938. We found the code that basically kept repeating itself, saying welding is not allowed. Now, the main reason why welding is not allowed is because it's not properly maintained, if it's not properly done by the right person with the right credentials, certified welders, for example. What tends to happen is these fire escapes eventually will fail. So as we go through here, you see that this fire escape that's rotting into the ground needs repair. The treads that are sitting here, as you can see, somebody did a temporary repair from above, a typical welding clip using an 1.5-inch angle clip welded from above, and then tack welding all the little angle bars of the grating. Well, this is an exact activity that occurred on that case that I'm now involved in New York City, where this exact repair was done as an emergency repair. It was let to continue as a permanent repair, and when somebody stepped on this, that's when it dislodged. It fell 8 stories, and it hit somebody down, a pedestrian down below, a passerby, as well as a woman. It killed the pedestrian. I don't know if it was instantaneously, but it was a fatal fall of a piece of fire escape. Now, how does welding tie into and bolting tie into load testing? It is our belief that if there was a load test performed on that fire escape system, that some of these repairs would have been identified as improper repairs. Some of the welds would have been identified as improper welding repairs because the rust had remained. And some of the bolted repairs would have been deemed improper repair because the rust remained inside, even though they changed some bolts. Okay? So before I go on to the next slide, does anybody have any questions right now on just some of the things that we're talking about in preparation for a load test? Nobody having a question about the load test? Let me move on to the next slide. I don't know if everybody's mic is on. Warren, everything is still on and recording without a problem? No, I have it on, but I just want to make sure that. All right, so I hear some. Does anybody have any questions so far? That this type of repair, whether the clip is welded from above or welded from below, welding is not an approved method of repair on any, because the process of fabricating a new fire escape, welding is forbidden. So in the repair of a fire escape, unless it's an emergency repair, temporary shoring of any kind, welding is not an approved method of a structural repair of any fire escape. Okay, let's take a look at some of the underneath typical repairs. As you can see here, this is typical of a repair done by what we call the welding witch doctors. As you can see, the bottom right-hand corner, you can still see the existing square head bolt fully rusted tread fire escape. And as you can see, very typical to have a welder, not necessarily a certified welder, come in and weld the nose of the tread. Now, back in the day when lead paint burning was not an issue, back in the day when you were supposed to pull a fire permit on these things, this was a typical repair that in some cases, if not caught, went from a temporary repair to an actual permanent repair. But with the rust still in the connection, it was only a matter of time when the expansion of the internal rust that's still in this tread clip would rip and tear and snap that existing weld. Does anybody in our group have any welding experience or any welding knowledge that they'd like to either concur, not concur with the statement that's being made now on picture number 4? Do we have Alan out there? Do we have Sean?
Yeah, I'm here. I mean, the welds were, from the fire escapes that we inspected, had the most rust accumulation. And I can see why, it's not proper to repair anymore with welding because of how much damage it can do. And you can't really see the failure sometimes until it's too late.
Correct. The some of the key, and I will add everything that you see here in the fabrication of a fire escape, clearly defined in the code of 1938, and I don't think there was any changes till 1969, based on the documentation that I have. It basically specifies exactly what size bolt that you must use, where welding is not allowed on a structural member, how certain pieces that were even for brackets had to be taken and drawn from a piece of steel and would have to be heated and hammered to create a 1-inch round or 3/4 round shaft to then be to put a nut and on the back end to basically have it threaded so it's all one piece, welding not allowed. It talks about railings and how they cannot be welded. They have to be lap jointed and bolted, and a lot of reasons is because as the fire escape heats and contracts, that in itself, it needs to be able to move. So that's the incorrect repair that has happened nationwide for over 50 to 75 years is the typical picture number 4. It is this type of repair that has now, for the first time ever, to my knowledge and in my involvement, caused a fatality of a passerby. Now, I'm not going to get into too many details of the case. I'm just going to identify the zone. It was on Broadway in New York City, on the corner of another street in Broadway, and it's a very heavily pedestrian occupied area, and this fire escape system was 8 stories tall. So to have something fall 10 feet or 80 feet, obviously the results could be an injury to a fatality, and this is the first time I've ever had a fatality of a component of a fire escape falling to the ground and hitting an innocent passerby as well as a second person on there. If you look at picture number 3, which is to the left of it, this is another typical repair when the clip is totally missing. Very common for people to come in and use a square bar or a round bar or even another clip. And as you can see, the biggest issue is who's welding. Now, what I did on this is when I removed this fire escape from its position at the school, I actually did all this work to it by creating something that I could show people just what is being done out there. So some of these welds, they look fresh and they look new because I created them. I did them to sort of show the example of what happens when, somebody has disregard for the proper repair of a fire escape, is not aware of the laws associated with the fabrication and or the repair of a fire escape, as well as no regard for the life and safety of the firemen and the tenants, because a lot of times these welds do cause a fire. And I have a video of that occurred just a few years back in 2014, where we lost 2 firemen from somebody welding a fire escape exactly like this. Okay, so let's continue. As you can see on picture number 1, as you can see, even though the metal has deteriorated, there's nothing there. It's not uncommon for them to keep welding even on bad steel that has deteriorated beyond its useful life. So the typical repair done by a welding, what we call them the welding witch doctors, aside from putting everybody at risk, they will weld to anything. And as you can see, welding is not an approved method of fabbing. It's not an approved method of repair. The picture number 2, as you can see, those are showing that the nuts are gone. The shaft is still there, and this is what causes a lot of false interpretation of a fire escape examination. You can physically step on that thread, and it's not going to fall. It's wedged in there through compression, rust compression. The nuts are gone, but the shaft is still there, so the shaft is not letting the tread fall. So it's not uncommon for you to get an opinion from somebody that says, hey, I walked up and down the thing, I was jumping up and down, nothing happened, it's great, you should just pass it, you know what I'm saying? But these are typical situations that if I was to examine a fire escape using a confidence test, a simple checklist, every one of these pictures would have stopped me from proceeding to a load test. Picture number 1 would have shown deterioration and welds and rust not removed. Picture number 2 would have shown me that certain components are missing already, deteriorated away. I can no longer proceed to a load test, and that there's internal rust visible as well as surface rust. There's 2 types of rust that you have to deal with. Fire escapes must be structurally sound and must be kept painted. Well, guess what? The fact that it has not been kept painted is already making every single connection suspect. But visually, I can already see that there's internal rust. There's deterioration. There's deflection of some of these steel members and connections, and that doesn't happen other than having internal rust pushing its way out. Picture number 3 is an improper repair with a simple half-inch bar and tack welding. And picture number 4 is very typical of somebody welding the nose and quickly getting some paint on this thing. And as you can see, it's not even a very good weld to begin with. And this is what causes the majority of the fatalities and or the injuries out there, is a fire escape that gets welded today. The internal rust on that connection grows a 1/16, and that basically snaps that weld in short order. It's not a matter of if, it's when. So this is a staircase. Like I said, I took it. It used to be 4 feet apart. And what I did to it is I basically took it apart and I welded. I created a short piece that I can take on trips to do classes. And from those classes, I'm able to explain to people just what a fire escape looks like that has been totally ignored. Now, I changed this fire escape out in the Christmas break. And the saddest thing about this particular fire escape is that it was brought to my attention not by the fire department, not by the building department, which performs yearly inspections at this school. It's a private school, kindergarten through 8th grade. But it was the facilities manager who brought it to the attention of the principal that says, we got to change this out because this fire escape is very dangerous. And the kids use this fire escape every day. Their hands ran over this fire escape that had lead paint every day. So I thought it was worth keeping, and I thought it makes a great model. Whenever I can, up and down the East Coast, I bring this to many shows, and it's a great touchy-feely kind of fire escape system that lets people see just how bad things can get that are 50, 75, sometimes 100 years old. This is the existing fire escape on the left. Again, as you can see, it's an elementary school. I took this down in 2011, and I put it back with a brand new code-compliant fire escape, as you can see. And not only was this fire escape not painted, full of lead, and major structural issues throughout that obviously I was able to save and embedded into the asphalt. But when I put it back, I made it feed to the right side and up against the wall, because children were also banging their heads and hanging underneath this, because this was a recess yard. Children were getting injured just by hanging out underneath this particular fire escape. So I'm about to continue on and go into some confidence tests and talk about that. But do we have any comments? Do you have any questions in regards to some of the issues as we get into this load testing and welding and bolting of fire escape systems?
No, I'm good so far.
How about was it Minnesota that is fairly new to the game plan?
Well, I'm just listening in, and so far all the points make a lot of sense. I don't have any additional comments at this time.
Perfect. Okay. So anybody else want to make a comment in regards to, and I know that for one of our guests is Stu. Stu is out of Portland, Oregon. It's actually one of the model cities that we're going to be talking about. Seattle is another city that when I first started doing seminars, I was brought out there because there was a tragedy that occurred. There wasn't a fatality, but there were some injuries. 4 people fell on a fire escape on the second or third floor. From there, I was able to meet with Stu in Portland. And Stu, the only sticking point that we currently have with Stu, I don't know if, Stu, your microphone is working or not, but Stu is currently load testing this style fire escape up to 200 pounds per square foot, which is one of the things we currently disagree with, but we're all working together to see if you know, the 100 pounds, which is the national model, should be standard, as well as if you do a full refurb, there is no need for a load test, as long as you verify not only the connections on the outside, but also the connections into the inside of the building, where we're in compliance with the NFPA, which states the authority having jurisdiction shall accept by load test or other evidence of strength. So this is the model we're trying to present, but at the same time, every state, every city, they do adapt and improvise some of the documentation, some of the examinations, some of the testing requirements, because this is fairly new on something that's very, very old. So, Stu, are you out there? In some cases, the microphone, you can hear things, but you can't, the microphone is not working, so not all times does it technically go off without a glitch. Let's move on, and let's talk about confidence tests. Now, one of the first confidence tests I have ever created was for Seattle. It was simple, 25 questions. I believe I hit every single component of a fire escape. What is a confidence test? A confidence test is just a checklist that should be utilized throughout the country, so that all architects, all engineers, all technical specialists use to basically agree that every component of a fire escape is either yes, no, or not applicable. So let's go over the confidence test, and this confidence test is what must be passed in order for you to even go to a load test. So the reason to have a confidence test is to say, yes, everything checks out, let's load test it. Okay? Now, it is our belief that during a confidence test, if the yes is yes because I changed every fastener on the fire escape at these components, and the remaining steel looks as good as of the date of its installation, and then I've verified the connection into the building in some way, somehow appropriate to the building official, then there is no need for a load test, because I've satisfied what's called other evidence of strength. Other evidence of strength in some states is actually the signature of the building official. I mean, of the architect or the engineer. Some building officials will take a load test as a simple signature on a piece of paper saying ready for its intended use. It's called an engineering analysis. So we're trying to make sure that everybody understands that there's got to be some standardization out there to help everybody answer all the same questions. So I'll go briefly and quickly over the pages of a typical competence test, which, by the way, you go on seattle.gov, you're going to see a sample of these 25 questions. You go on portland.gov, a sample of these questions. You go on la.gov. Their Reg 4 has a questionnaire. You go into Boston, Lowell. There's always some city as they start to move forward and they have a questionnaire. A lot of times the questionnaire did come from the National Fire Escape Association. And what is the questionnaire? It's just identifying what is potentially the only 25 things on a fire escape. And so this is probably the fourth version, and we try to make it better all the time. But it's basically, I'll go one by one so you guys can understand that if you use this standard confidence test or create one of your own using these as a basis of your questions, then you're going to find that most fire escapes will have a standardization of inspection before load testing, and then a standardization of inspecting after load testing, or a standardization of load testing to avoid, in lieu of load testing, provide somebody with a document that says other evidence of strength was covered. So let's talk about the page on the left. Top left is name and address of the owner and the agent. Sometimes it's two people, sometimes it's the same. In the middle of that, you want to sort of have a plan view of where this fire escape is. If the front is the street, the back is the back of the house, because sometimes this east, west, north, south does get confusing for some people, but everybody knows the front of their house on the front of the street. And you just basically create a box, a rectangle, and you put another box, and you put an X in it, and that tells you where the fire escape is relative to the front street. The next one is going to be who's the authority having jurisdiction, the professional acceptable to the building official. Who's this professional? Design professional. Could be the structural engineer, registered structural engineer in that state, registered architect in that state. Now, for example, Philadelphia does not allow architects to sign in Philadelphia, but architects can sign in the state of Pennsylvania. So some states can even prohibit certain people. And the last one that can sign this is somebody that's either certified as a fire escape inspector, licensed as a fire escape inspector, or a technical assistant classification, which I'll cover in a little bit when I get into the code. The next questions, as you can see, is if all of a sudden somebody did repair this fire escape, we want to know what that vendor's name is, name and address and phone number and license number, and more important, did they require a permit? As you know, it's a gray area. When you paint a fire escape, no permit needed. When you maintain a fire escape, change fasteners here and there, or all of them, some cities, some states say you don't need a permit for routine maintenance. So that's your call per state, per city, per location. This document says that I'm handing you a pass-fail, or I'm handing you a technical repair report that this confidence is not. This confidence test is a checklist. A technical repair report is a very detailed report. So confidence test tells you what the problems are, not where they are and how many exist. A technical repair report, which includes this confidence test, is the back end, the back-loaded end, is a report that tells you what it is, where it is, how many, how to fix it, what to do with it, and that is usually the document used to pull a permit, okay? The four possibilities in load testing is next. So the fire escape results, passed or failed, or life safety, yes or no. Life safety means there's an imminent danger. Imminent danger means it's going to fall, and you may not even get on it because that's how bad it is, or it has already fallen. The entire piece has already fallen, the tread has already fallen, the rail has fallen, something has given way. That's a life safety concern for the tenant. That's a life safety concern for the city official. And usually that has to be remedied within 24 to 48 hours. The questionnaire says, I'm going to certify the fire escape in one of three ways. Certified by load test, certified by other evidence of strength, and the last one is, which is most common and been used for 50, 75 plus years, has been the fire escape is certified by opinion affidavit. acceptable to the AHJ as ready for its intended use with an opinion disclaimer of liability. A lot of them don't know it's in there, but every architect, every engineer squeezes it in on the last page. To the best of my information, knowledge, and belief, the fire escape is in conformity with the building code of that state, that city, or that jurisdiction. Okay? So that is the three options of certification, when there really is, the code says there's only two: load test or other evidence of strength. But the opinion affidavit has slipped in here, and it has been used for many, many years. Okay? And the last one says inspection, evaluation, determine that the fire escape failed. The fire escape is either not structurally sound or it has not been kept painted. You need both in order for it to pass. Down below is designation areas for you to sign, so that you can basically identify to the city who you are, what you're licensing. Let's go to page 2. At the very top, repeats whether it passed or failed, life safety issues or not. And we're looking at the typical components that are going to be looked at on this fire escape. Overall, so if the fire escape has any deficiencies, 1 or 2 or 3 of these situations have a concern or a defect, then overall you cannot pass. You have a poor fail. So treads can pass, it can be fair or poor. Stringers can be fair or poor. Rails can be fair or poor. Structural can be fair or poor. Cement into the building or cement at the ground can be fair or poor. Paint can be fair or poor. Grading or platforms or diamond plates or cement slabs can be fair or poor. Ladders that are fixed or balanced are going to be fair or poor. Cantilevers, weighted systems are going to be fair or poor. And catwalks are going to be fair or poor or missing in some cases. So why fair and poor? That's sort of the line of something that's 50, 75, 100 years old that's been recently painted. If it's in good order, it has to be fully refurbished and painted. If it's in excellent condition, it's brand new. And obviously you can see down below, life safety, pre-existing, missing, not applicable, applies with that quick checklist. So let's take a look now, before I get on to the 25 questions. I believe that the 25 questions I'm about to ask for a yes, no, or not applicable touches every fire escape you've ever known in your entire life. But before I continue, does anybody have any questions this far on the confidence test? This is just a generic, typical confidence test that's available on the National Fire Escape Association website. Anybody have any questions? Hearing none? Nobody? Seeing? Okay. So let me go line by line. Again, you can all print this out, go to any one of the websites, click on typical confidence test, and there's a blank version of this. And if you want to make up your one for yourself, just take the same questions and just put it on your own letterhead. So if all of a sudden you don't want to use this document, just take these 25 questions, put it on your document, your letterhead, and answer them as best you can for the official to determine that there was a proper steps in the inspection of the fire escape. Number 1, it's all fabrication, installation, and maintenance of the fire escape is to code and met industry standard on the date of installation. So anybody that's familiar with fire escapes, when you get there, you're going to be looking at a factory-made fire escape. It looks like all the other fire escapes, and believe me, it's that standard. Most of the fire escapes were built in the early turn of the century, in the first 25 years to 50 years in the 1900s. Everything was built, and the majority of them were built out of factories, not out of ornamental shops. Okay? That's what question number 1 is really asking you. Is this a homemade or is this a factory-made, industry-standard fire escape? So this is not asking you whether the fire escape is good or bad. It's just asking you, what do you got here? Is it an industry fire escape or is it a homemade? Question number 2, is there any pre-existing non-conforming issues that you need to speak with the building official? That's the homemade question. Number 2 is the homemade. And it says, yeah, it's got chicken wire here, it's got plumbing tube over there, it's got treads that are made of wood, you know what I'm saying? So whenever there's something that's not conforming, you want to talk to the building official because they're going to have the final say as to whether or not the pre-existing non-conforming will be acceptable as is, because you're going to need that in writing. Number 3, all welds. All welds pass visually on this statement here, but it must be X-rayed or load tested because welds is not a common method of fabrication of a fire escape, as well as welds are not an acceptable means of repair, but they're done. There's quite a bit of it out there. So your job is now to identify these welds as either part of a factory fabrication, meaning it was all shop welded and then field installed with bolts, or in some rare cases, you get there and the guy showed up with a bunch of steel and just welded it on the back of this building, which is not acceptable. You know what I'm saying? It's right in the code. To fabricate a fire escape, they allow shop welding of certain components, but they all must be field installed with bolts minimum 3/8, and it's clearly identified in the specs that I have identified in some of my expertise review of codes. And the granddaddy of all the codes really is coming out of New York City. If there was ever a place where they kind of figured it out, it's New York City. And so New York City has quite a bit of the code on brackets, on railings, on splicing, and clearly it repeats itself over and over and over again. Welding not allowed on major structural components in the fabrication of a fire escape. Well, that only goes to say that welding is not allowed as a form of repair of a fire escape. It could be a temporary repair so that you can come back and then rebolt it accordingly, but welding is not a form of repair on a structural component of a fire escape. So because of that, we have to load test it or X-ray it. But that can, a weld can be easily negated by popping a bolt. So you take a welded connection that has no visible internal rust, you drill a hole, you put a bolt in there, you've eliminated your concerns, okay? Number 4, overall the fire escape system passes. This is overall. This is all the components combined. Does it all pass? The answer is yes or the answer is no. So this is sort of the whole body, the whole patient. Number 5 covers footings, and some fire escapes do have footings to the ground. Number 6 is the walls of the fire escape, not where it attaches into the wall, but the physical entire wall of a 50, 75, 100-year-old structure. Is it bowing? Is it bending? Is it bulging? Well, we need to know that because that's a totally separate inspection. That's a totally separate permit. That's a totally separate investigation. That's an envelope inspection that should never be part of a fire escape. And by the way, this question is very important if you're going to load test it, because if the wall has any damage to it that would deem it unsafe to be load tested, it prevents the load test because of this question. Your wall has issues. Bad mortar, bulge, ice jacking that you can clearly see, major structural cracks on a wall. Can't load test it. I'm not going to. Number 7 is supports into masonry wall. These are usually embedded 8 to 12 inches deep. Through bolts into a wood structure. Well, that's typical. There's a lot of wood structures. Every single wood structure has a one-piece through bolt that goes in. So in the past, they would take a piece of flat, forge it, and hammer it until the flat at the back end would become a round piece. Then they would put some thread on it, and they would have a 3/4 or 1 inch threaded rod, all one piece, no welds, with a plate on the inside that has specific sizes to the through bolt plate on a wood structure, picking up the studs on the interior of a wall. Now, the same thing applies if you're going through some masonry buildings where they did not pocket it into the building. They actually did a through bolt into the building, and so it's not uncommon to see some factories and some other structures, even though they're masonry, also utilize the through bolt with a plate on the inside on a masonry. But majority of the time, number 8 applies to wood structures. Number 9 is talking about the platforms, and these platforms can be slats. They could be grading. They could be mesh. They could be cement. They could be cast iron. They could be wood. They could be angle, and you have to identify all these. By the way, cast iron is not an acceptable means of fabricating fire escapes. They quickly learned in 1938 that cast iron is very brittle, and any form of rust jacking that exerts a force on cast iron cracks it. And the only way you can keep cast iron on anything is you have to put this 1 inch solid reinforcement bar underneath as proof that that cast iron has now been supported by something other than itself. Otherwise, it is forbidden to use cast iron anymore, or as early as 1938, they realized that prior to that they were using cast iron treads and cast iron platforms. It's forbidden. You can't use cast iron. So whenever you run across cast iron, replace it, because there's no way to load test it without, fear of hairline cracks that are not seen becoming a problem. So cast iron is once identified, remove and replace is the norm. Stringers, the strings of a stair, they call them strings, upper and lower. They have a mandatory bolt connection on the top and a mandatory bolt connection on the strings at the bottom. So that's all this is about. Stair treads, whether they're plate, slats, grading, they too are now in need of an inspection. They're probably the one of the most critical pieces of a fire escape is the treads. And a lot of times they're the ones that have, due to manufacturing techniques, they accumulate rust and dirt and debris in the crevices on the left and the crevices on the right, and that's from East Coast to West Coast. That's where snow sits and just feeds the water in there. Rust jacking occurs primarily on the top, bird droppings, tree leaves, dust. So sadly, the moistest part of a fire escape tends to be the treads on either side. And so if you see anything internal, it's an immediate violation of the fire escape. It cannot be load tested. And in some cases, depending on the state you're at, by removing the tread in its entirety, cleaning it, priming it, and putting it back with new bolts, and then sealing that crack and crevice from the top with 35 to 50-year paintable silicone, there's no need to load test that tread. All right, so, and number 12 is railings. Railings on platforms, stairs, catwalks. This is about every railing that you see, whether it's going down the stairs or whether it's on the platform. If any of these railings are welded, again, not allowed by law. You can splice railings in the same direction, or if you're going to it's going to take a turn and go back to the wall, unless it's a one-piece forged radius turn. It must have a lap joint and it must have a bolt. It's clearly stated in the fabrication techniques of all fire escapes. Okay, so I'm at question number 12. There's another 12 to go. Does anybody have any questions so far on the components that and the entire system? Have we covered so far? Have we covered so far or does anybody have any questions so far on what I've covered so far? Any agreements or disagreements? Seeing none, I'll move on to the next page. Hold on. All right, number 13, fixed ladders to roof and to grade. A lot of people don't realize that a ladder to the roof is primarily for vendors to repair roofs or for the firemen. It's primarily for the firemen. Very few people will egress up in case of an emergency. A lot of fixed ladders and goosenecks have a mandatory standardization of going up. So if you have a ladder to the roof, it must have gooseneck going up and over. The rail bar must meet the roof line. They must be a minimum of 15 inches, but on average, they're usually 16 to 18 inches wide. There's an attachment procedure on the gooseneck up on the roof and or onto the parapet wall. There's a minimum for your toes to be, again, away from the wall. And there's an attachment requirement not only at the bottom of a ladder, it must be bolted to your platform. There must be 2 attachment points to the wall going up the ladder, and then the gooseneck has its own attachment requirements. Those are all points that are going to be load tested, or all points that need to be observed as not requiring load test because you've changed the bolts out or you've done some other form of testing. Number 14 is balance ladders. Balance ladders are basically weighted ladders only at the bottom. There's no balance ladders up on roofs. So a balance ladder is primarily over a sidewalk, primarily used so people don't break into a building. Balance ladders, once released, drop 2 to 3 feet per second, hit the ground, and stay down. Now, with these balance ladders, what you have is you have maintenance requirements. In some cities, such as San Francisco and LA, they make you inspect the balance ladders every year. Yet the fire escape system is only inspected every 5 years if they're current with the current code of 5 years. But otherwise, prior to that, there was no 5-year rule in the state of California to inspect the entire system. Other than in San Francisco, they had a 5-year rule to inspect the entire system. But a lot of people did not apply that unless they got a letter. So in Berkeley or Oakland, if they didn't get a letter from San Francisco, they weren't inspecting their fire escapes every 5 years. And then the national code or the code of California did not have a 5-year rule. But a majority of the inspections happening in all of California were primarily ladder inspections in LA and ladder inspections in San Francisco. And that's because of the moving parts. Number 15, cantilevers. Cantilevers, it's a moving piece. It's balanced. It's very intricate. It's like a watch. You got to make sure that, some of these are made to activate in 2 ways only. You can have a release arm on it so that when you release it, it by itself, without you even stepping on it, drops 2 to 3 feet per second, hits the ground, and stays down. It literally weighs about 25 pounds on the nose more than the rest of the weight box, and it just drops by itself. It's also acting as a release arm, as a anti-theft device, meaning you can't pull it down. There's a release mechanism up above that only somebody from up above can release the cantilever. Firemen can get to that by using their ladders to get on the platform, releasing the cantilever and letting the firemen up the fire escape, and people egressing out of the fire escape just by going through the single action requiring no special knowledge release arm, basically activates the fire escape and it drops. The second method, which is very common throughout the country, is called the weight balanced, meaning it's perfectly balanced so that you stepping on the first 25% of the treads, basically your weight counteracts and drops it to the ground. The only problem I see with those, even though it's legal, is that once you step off, it goes back up. So if there's a fireman there that wants to get up your ladder, unless he has a pike pole, he can't really pull it down. So the biggest issue with fire escapes is, especially on cantilevers, is break-ins, proper balancing, release arms. Do you want the person to activate chains that give you a false sense that the fire escape is balanced because of the holding it horizontal? So this is what that questionnaire is here. If there's a concern, number 16 covers all concerns because it's just a yes/no. And there's some space in these confidence tests to give it a little bit of a note saying what's your remark associated with that. Because don't forget, confidence tests tell you what the problems are. They don't tell you where the problems are and how to fix it. That's a technical repair report for permit. Okay? Let's go to number 17, all components in doors and windows. This is very important. Does it look like the doors coming to the fire escape and the windows coming to the fire escape, do they look like they're operational? A lot of times we can't be there opening and closing windows or opening and closing doors, but this is just us saying they seem to look good or they're junk. They're falling apart, and this is a great way for you to disclaim that you didn't take a look at those things. Those are here to basically say those need to be addressed. Number 18, all electrical power is 10 feet away. This is very common. There's a lot of fire escapes that are within 5 feet, 3 feet of the electrical main line coming in, and if there's enough water being pushed upon the property and near the fire escape, there's a possibility of electrocution. This also means electric power means AC units, other types of electrical equipment physically attached to or onto the fire escape system that could cause an electrocution of some kind. So that's noted here, number 18. Number 19, overall, the fire escape is not illuminated. Well, a lot of people don't realize that a lot of fire escapes did not require illumination. So we have to note here that even though it's not illuminated, it's unacceptable because we're certifying the fire escape as of the date of its installation, not of today's code, but on the date of its installation. So the 36-inch high rails is fine. The 2-line rails is fine. The no illumination is fine. The 22-inch treads is fine. You know, so there's all these things. You're going to have to know a little bit of history to understand whether or not that fire escape that you're certifying that was built 50, 75, sometimes 100 years ago, did it meet all the requirements of the certification back then? So you do have to have a little bit of knowledge of history of what was acceptable and not acceptable. But the beauty is that a majority of these fire escapes built by factories, they all follow the same guidelines, the same criteria. Very few fire escapes are not code compliant, and a lot of those are homemade, or it's somebody who copied a fire escape but only reached 75% compliance. Those are easily identifiable. All right, let's take a look at the overall. The fire escape has no interior or exterior obstructions. AC units and windows, plants, garbage, bicycles, can collection, my God, chairs, lounging chairs, you know, satellite dishes. That's what this question is about. The next question for number 21, there's no storage of flammables, you know, snow plows underneath, motorcycles with engines, anything that is, you know, gas, propane tanks underneath your fire escape. Very common. We have to let people know you can't have those things there because basically it'll take away the second means of egress. Okay. The next question, the fire escape is made of what? Majority of them are made of painted steel. In California, a majority of them are made of galvanized steel. In some areas, you're going to have aluminum, which is an acceptable means of fabricating fire escape, but it's a very small percentage, less than 2 to 3% of all the fire escapes I've ever seen nationwide are aluminum. Some fire escapes are made of wood, so sometimes a egress system does match the building type. So a wood structure will have a wood fire escape. It does have its fire rating requirements, but again, each on a case-by-case basis, there are times when a wood fire escape is an acceptable means of egress, and it has to be inspected every 5 years. Mix is a combination of the two. Some people have a metal fire escape, and they replace certain components with wood. You can also have a mix where you have a metal fire escape that has cement. And other is, you know, there's even fiberglass fire escapes out there. Very few, but there is some fiberglass fire escapes out there. All right, the system has been maintained and weatherproof. This is the painting question, you know, and so in order for it to pass, it must be kept painted, because if you don't paint it, then you're allowing the water water intrusion into a connection, and as soon as a connection is suspect, you can no longer pass it. So an unpainted fire escape basically is stating that all the connections are suspect. So if you see a fire escape that has not been painted 15 to 25 years, it's pretty confident to state that, you know, all the connections are suspect. It's structurally unsound, and then again, you may be able to wire brush it, clean it, and identify that even though the paint is all off the fire escape, it has not gone internal. But as soon as the rust has gone internal, now you have a different type. That's called rust jacking. That's called internal rust. Internal rust needs restoration. Surface rust needs repair. A repair is scrape it, paint it, remove what you can, and a lot of times it does not include changing the bolt. In some cases, when the bolt head or the nut is bad, you still can repair it by changing the bolt, but you didn't have to separate the connection. That's called a repair. Routine maintenance and repair is scrape and paint, occasionally change the bolt, but no separation of the entire component in its entirety. You scrape it, you paint it, and if you can, you got to silicone shut it so that water doesn't get inside. But as soon as water has gotten inside and you got a 1/16, an 1/8, a 1/4 inch, 1/2 inch of rust jacking in the connection, you cannot repair that. You can't weld that. You can't do it. That entire component needs to be restored, and that restoration process could take 15 minutes to half hour, whereas a scrape and paint will take 2 to 3 minutes for that same connection. And that verification process for the engineer who's going to come back and look at it is very important. If there's 500 connections on a fire escape, the architect, the engineer, or the specialist who is going to be inspecting that fire escape, doesn't want to let anybody fully paint the fire escape. They want to get there and see primer 2 inches beyond the repair, and they want to see a new shiny silver bolt, and they also want to see black eyeliner, which is the paintable silicone, latex silicone. In case they ever change the color of the fire escape, latex silicone will take different colors. It won't peel it off. And that's a properly restored system. And in some cases, that properly restored system gives you the additional advantage of meeting the NFPA other evidence of strength. Now, with the other evidence of strength now comes also the connection into the wall, and we're going to cover that in the next up-and-coming slides. Any questions so far on this piece? Actually, let me hit number 25. 25, as you can see, a lot of space in 25. It's the catch-all. This is when you say, I've got a very unique fire escape that has PVC pipe, has a chicken coop. They've suspended, a flagpole from it or something. Anything that's unique and specific to that fire escape that you don't normally see on other fire escapes, put it in number 25. Okay? And we tell you the steps to certification. Repair report, if the fire escape failed by a design professional or others, must be made so that the building official can determine whether a permit is needed or not. In either case, a repair report is mandatory. Permit by licensed vendor with an EPA license. Again, the permit, if the city official chooses not to ask for a permit, and again, it's the building department, not the fire department, that makes usually that decision. They got to be progress inspection. So if you're the engineer of record, you got to be there 3 times. You got to be there in the beginning when they start the project, pat them on the head and say they're doing a great job. Surprise visit in the middle to say, hey, you're doing a great job. You're doing exactly what you did at the beginning. And then a final saying that everything looks good to me. The fire escape is painted, structurally sound, and that will then put it in the hands of the AHJ as to whether or not he wants a permit sign-off. And then, obviously, the submission of the certification by a load test, by other evidence of strength, or an opinion affidavit, okay? And obviously, number 5, repeat every 5 years. The next page, as you can see here, has a lot of terms and frequently asked questions, including the IFC, the IBC, the NFPA, OSHA 1910.37, as well as the technical assistance code is on there, just to help you understand, why there's 3 people that can look at fire escapes: structural engineers, registered architects, licensed or certified fire escape inspectors, as well as technical specialists that the AHJ has deemed satisfactory to them, or that the AHJ has deemed satisfactory but still wants peer review done by an architect or an engineer that's registered in their state. Okay, let's open it up to questions. Any questions so far on what we have here? No? No questions? All right, let's continue. We're going to continue on to load testing very shortly. Here, as you can see, this is guidelines as well as a vendor sheet, usually made so that the vendor can be qualified. A lot of times the homeowner does not, or the business owner does not properly qualify the vendor. So make sure that the vendors fill this out so that you know that the vendor you're about to sign off on has a license, has insurance, lists you as an additional insured, understands the EPA rules about not welding on something that has lead paint. And this is for your own protection that he fills this information out, because it has some references in here of the last 3 jobs they've done. Not only does the homeowner want to have a comfort level with the vendor, but the architect, the engineer, or the specialist who's going to sign off on this work needs to have a comfort level. All right, existing examples out there. So we've been teaching this system for 10 years nationwide. So if you want to go to one of our top models, go to Portland, Oregon. Right online, just go to, type in on a search bar, type in fire escape issues, Oregon, Portland. and they've got it all written down, the types of bolts to use, all the codes, paints that you should use, everything's on there, okay? You've got Seattle. Seattle was one of our first confidence tests. As you can see, they just basically copied our confidence test, and it's not the full 25 questions, but it's all yes, no's, and not applicable questions regarding certain connections, certain components, about the electrical. It's all there. So if you want to go onto their website, and as you can see, they have 22 questions, and then if there's deficiencies, they want you to write it on the right side. The problem is that these deficiencies is really an opinion affidavit. I'm sorry, is an initial inspection report, and it's going to be limited. You're really going to be telling them that the fire escape failed, here's why they failed. But this cannot be used as a technical repair report telling you where it is, how many exist on the entire system, and exactly how to fix it. That's not what this is. And so these deficiencies, you got to be careful that nobody uses these deficiencies to reverse engineer your project and then only call you at the end when it was all done wrong. So you got to be careful that you understand that you tell your clients you're inspecting, you're doing a pre-load test evaluation so that you can proceed immediately to a load test because they passed with their old fire escapes and their old bolts, and there was no internal rust anywhere. Or you are telling them that the fire escape, if you change all the old bolts and you've repaired all the fire escape systems as identified in your technical repair report, you're going to do no load test, or you're going to do a partial load test because some of the components and some of the system passed because it was, what's the word I'm looking for? It's a partial load test of the remaining components that were not changed or fixed, but were in good order, indicating that there was no internal rust on any of these connections, okay? So be careful of that. Coming up with tags, Seattle, red, yellow, and white tags. They were the first to come out. Even though if you check your fire codes, all fire protection equipment must be tagged, yet fire escapes were never inclusive in fire protection equipment, even though in one state it is, in the other state it is, but it's not really. But it is nationally known as fire escapes are the bastard child of egress. So that is one distinction it does have, and that's why it's forgotten. It's not watched. It's not maintained. But now we have a crisis on our hands, in that the fire escapes are so bad. Not only are they injuring tenants, injuring firemen, but now they're also taking the lives of tenants, the lives of firemen, and also now taking the lives of innocent passerbys, okay? These are some guidelines for the National Fire Escape Association for inspection, for the repair, and for the painting. Pretty standard, as long as there's some sort of standard out there. And the standards are, in 2012, the IFC basically stated that all fire escapes should be inspected. Majority of the states nationwide now have adopted minimally the 2012, if not the 2015. So there is a 5-year rule now everywhere to inspect fire escapes every 5 years. That's probably one of the best things that have happened in 2012, is that whether you've adopted the IFC 2012 or the IBC 2012, everything is requesting that you load test. The NFPA is very important here also, and that is the authority having jurisdiction shall inspect, shall be permitted to approve any existing fire escape stair that has been shown by load test or other satisfactory evidence to have adequate strength. This statement by the NFPA is what you have to reverse engineer back into the code, testing and certification. All exterior fire escape systems shall be examined and or tested. So if they're asking you where's that say that, you have to reverse engineer it back into the statement. So the tested up above in the code is load testing. Examined is the other evidence of strength. So in some states they call it an engineering analysis, reverse engineer analysis, reverse load testing. I mean, you have so many different names, but examined meaning that some of the city officials will accept your signature on any piece of white paper that they can stick in the folder of that fire escape because they believe your insurance is going to cover anything that occurs on that fire escape in the future, okay? So, Maureen, you want to shut that door? 'Cause OSHA code, very important. All exit routes must be maintained during construction, repairs, or alterations. A lot of you guys don't know or I'm not aware of, but if you're working on a current project and the second means of egress is a fire escape, that was supposed to be the first thing you certified. While the electricians, the demo, the plumbers, the plasterers, if anybody's working on a fire escape, that's what you were supposed to put up and certify first. Sometimes it's the last thing you do. So you're actually breaking the OSHA code 1910.37, which is you must have two means of egress. Now, for some reason, when you've identified that the fire escape is not ready to be certified, is not ready to go, and you don't want to delay the project in any way, it does say here that during repairs or alterations, employees must not occupy the workplace unless an exit route required by the subpart are available and the existing fire protections are maintained, or until alternate fire protection is furnished that provides equivalent level of safety. That could mean scaffolding. That could mean fire watches. That could mean anything that the fire department, the owner, and the building department have agreed to is satisfactory to continue on with the project. Okay? This right here, which happened in 1975, as you know, was one of the major reasons why we changed our 5-year rule. So 75 to 2005 is 30 years. To 2015 is 40 years. Okay? So 40 years ago, they changed the code in Massachusetts to inspect fire escapes every 5 years. And we're still having fire escape issues where people are not certifying their fire escape. This is the Pulitzer Prize-winning photograph, as you can see. The woman there on that day sadly perished. Her niece, which was 8 years old, landed on her. But as you can see, around her is grating, railings, brackets, plants. It was a 4-story fall. The child did survive. The fireman did survive also. The fireman grabbed the ladder with one hand and hung there until he was saved by his fellow firemen. So this is some examples of some of the issues we have out there. This is a penitentiary. So if anybody comes out of this penitentiary, this is a juvenile penitentiary. Aside from having barbed wire and chain link everywhere, it's not till you get underneath it that you realize that somebody can actually come out of that, not only get into a courtyard that's enclosed anyway, but maybe fall through and hurt themselves and injure themselves because the stairs all collapse. This is some examples of some schools and some buildings that we look at where the rust is not just a 1/4 inch, it's 1/2 inch. And once you got a 1/4 inch, 3/8 or 1/2 inch, and you're inspecting fire escapes, this is your problem. You guys see how bad that tread is? Now, if you're coming from above, you'll never see it. If you're coming from below and you're not hammer testing, you'll never see it. Okay? Now, fire escapes just don't hurt firemen and tenants and passerbys. But if you can take a look at the first picture on the top left, that's an example of work being done. And sadly, one of our fellow brothers on fire escapes in Chicago, his father, 57 years old, doing that kind of work, fixing a fire escape, fell from the 7th story to the ground and died. So even the repair of fire escapes is dangerous because it's a deck of cards that have not been touched in 50, 75, sometimes 100 years. These are other forms of live load testing that occurs. People on parades, firemen during evacuations, EMS removing certain people from buildings that can't go out any other way. This is the true live load testing that's occurring as we speak now that is causing some anguish with a lot of city officials because some of these fire escapes do get used occasionally for special events of some sort or unique events, including emergencies. And as you can see now, very typical on the back, people need to get out. They have limited space, so fire escapes are becoming an area where people hang. But at the same time, with today's non-smoking policy, it's forcing a lot of people to go outside, including students, to smoke outside on the fire escape. So if everybody there was hearing that, somebody's got the, I think it's you, Mark, you got your microphone on? There you go, now it's up. All right, so that piece that I just showed there, basically, as she said, it came without warning. Well, actually, I taught a class to about 50 or so L&I inspectors to the Liberty chapter, not 6 months before that, claiming that the fire escapes in Philadelphia, which I have deemed to be the worst fire escapes in all of the nation, there's going to be a collapse soon that's going to kill someone, and that actually happened and occurred. And so because of that, the city 5 years later, out of the box, just came out with this requirement that every fire escape in the entire city of Philadelphia must be inspected by July 1. So July 1, they came out with it in 2017, and then within 6 months they wanted every fire escape inspected and load tested. And here we are in 2018, and we haven't even put a dent on the iceberg. Okay, so the key now becomes like, do we react because of a fatality, or do we have a proactive program that basically says, what are we going to do with these 100-year-old buildings, like Cincinnati? You know, they started doing their 75 to 100-year-old buildings. Now they're doing the 50 to 75-year-old buildings, and then they're going to do the 25 to 50-year-old buildings. So they had a 3-year program. You can voluntarily jump ahead and get going on it, but they started sending out letters and basically attacking it in a more paced way on fire escapes that were never inspected in their past. So this is what's happening out there. Fire escapes are collapsing. Fire escapes are having problems because people don't know how to build them, people don't know how to repair them, and people don't know how to load test them. This is another one here where the fire escape was basically being utilized by workers to get to the top floor. Now, fire escapes are not supposed to be used as a mechanism to bring materials and workmen to the top. But again, because the fire escape was not certified, this gentleman fell to his death. This is another one, somebody repairing a fire escape incorrectly. Students were watching fireworks. Guess what happened? The fire escape fell, hit the ground. 3 people were injured critically. And when they put the fire escape back, they put the fire escape back incorrectly because they repaired it incorrectly, and even the subsequent repair was done incorrectly. So let's stop right here at this time. Just let's see if anybody has any questions in regards to who people believe are inspecting fire escapes out there. Does anybody have any comments or concerns so far on everything that we've spoken about?
I have a question regarding replacement. Have you developed any list of vendors across the nation that just specialize in fabricating fire escape stairs, that kind of thing? Or
Yeah, the only company still out there is Fire Escape Services that specializes in just in everything fire escapes. It's Fire Escape Services. Now, as far as is there other people in your area that can build a fire escape for you with drawings from an architect or an engineer? The answer is yes. The people most likely that will build a standard, 3 to 5 story fire escape, or even a 10-story, is a ornamental ironworker in your area who does railings, window guards, and such with the proper direction from a registered architect or a registered engineer drawing the system. They can fabricate and install a fire escape system. As soon as you get 5, 10, 15 stories, you're probably going to be dealing with an iron worker because the structural activity on that is going to be of greater quality and greater quantity. And so a lot of times they're going to be using, cranes. They're going to be using pre-manufactured components to get installed in height work. So the iron workers will start touching things that are more in the 10-story range and above. But the ornamentals have, in your area, will cover the 3 to 5 story residential / mixed use.
okay, and another question. Yes, and another question, is the NFPA code something we all should have in our possession? That, for example, I'm familiar with the Minnesota State Code and IBC, for example, building code. What other resources are best to refer to regarding the code of stairways, fire escapes?
That's it. That's pretty much it. You know what I'm saying? When it comes to the additional code that you might have the technical assistance code. And that basically is it's the catch-all for anybody that's dealing with fire escapes that has an expertise that will satisfy the AHJ. And at the end, as you can see of the whole report of what a typical expert is, they still say the fire code official is authorized to require design submittals to be prepared by and bear the stamp of a registered design professional. So in some rare cases, some city officials, even though the expert is not a registered architect or a registered engineer, they may want peer review of the very same thing in order to satisfy that fire escape inspection, that fire escape build, that fire escape repair, whatever it may be. Okay? But the codes that you just mentioned, that's it. That's all you really need. You know what I'm saying? Because the one thing we're trying to avoid, as you can see on here, is that sometimes by not having a proper inspection technique, engineers and architects can not give you sufficient information to repair a fire escape, like this document here. Like this document here. You know, it's an early evaluation that people reverse engineer, thinking that they know what to do, when in actuality, the technical repair report would identify all these things that I'm now showing you in the photographs. You know what I'm saying? So it's very important that when you first step out and look at any fire escape, it's a cursory walkthrough. You know what I'm saying? And the best example of that is a doctor's visit. When you get there for your 15 minutes with your doctor because something hurts, it's, you know, somebody's taking your temperature, somebody's taking your weight, somebody's asking you a checklist of questions, you know, are you allergic to this and allergic to that? The doctor will see you in a few minutes. Once the doctor sees you and reviews the initial, and then he takes a further glance at you, he says, oh my God, you are sick, you're running a fever, you've got these spots on you that don't look good to me. I now need you to go get blood work. I need you to do x-rays, and I need you to come back in a day or two so we can review these, because you may need to get you may need surgery, or I need you to get to an emergency room right now because you're very sick, and that's a life safety concern. You know what I'm saying? So the code to build and fabricate fire escapes has been IBC. And in some cases, the fire code also covered some of the requirements to build fire escapes back in the 30s. But today, primarily the IBC and the IFC, and the NFPA. But throughout the nation, it's really the IFC that has the 5-year rule. In some states, the IBC references the IBC for the fire escape maintenance. But in some states, the IBC does have the same 5-year rule in the IBC. So out of 50 states, I found that about 10 of them, IBC still handles the fire escape inspection and load testing, like Massachusetts. And then 40 states, it's the IFC, the fire prevention, that handles all the examinations of fire escapes. Okay? Did that answer your question regarding what codes to deal with?
Yeah, that is helpful. One item, and maybe this is just something I need to look up in detail, but I know, for example, in new construction, if there's 2 means of egress that are planned for, you know, they're going to have specific requirements regarding, if it's a commercial building, a 7-11 tread pitch where the picket rail or railing can have more than a 4-inch gap between spacings, etc. And so, I'm a little unclear if fire escape stair is deemed, you know, just kind of totally needs to be replaced, or, you know, just it's beyond repair. Is that up to the building official to determine, you know, how to bring it up to today's code, or am I missing something where second means of egress, you know, doesn't need to comply with those requirements like a new?
Yeah, that's a very good question. So let's first of all get everybody on the same page. If you're digging a hole in the ground and putting up a building, you are not allowed fire escapes anymore on new construction, ever, unless you have some special variance, some special process that you went through. No one is allowed a new fire escape, okay, on new construction where you're digging a hole in the ground and starting from scratch, ever. Now let's talk about pre-existing buildings, including this fire tower here that firemen train on. You take any existing box, whether it's a church, a factory, or a residential box, you know, anything, and you want to convert it, and you can put a fire escape onto it by law, and nobody can deny you. Once you've exhausted all means of putting it inside, you're putting 2 means of egress inside the building. So if I get to a box that I just bought, and it's an old factory, and it has this beautiful central stairway, and it has a left wing and a right wing, and this central stair also has this elevator in the middle of the building. The fire official says, oh, I need a staircase way down on the left wing, and I want a staircase way down on the right wing, besides this central stair. The person that's doing the project might say, you know what, that's going to kill my project. I need all that valuable space, for rental. I got to rent that space. So you're allowed by law to put in a fire escape outside that building, whether that fire escape meets the 8 and 8 rule and 45-degree incline, 24 inches wide, 36 inches wide, 42 or 48 inches wide, or it's an egress staircase outside on those wings. That's between your codes of your specific area, but that fire escape can be 7-11, 36 inches wide, 48 inches wide, and it may need a roof cover so that ice and snow don't accumulate on this external egress. So there's a fire escape egress, and there's a egress, the second means of egress, external to the building, which has certain requirements. But all of them today do require 42-inch high rails, 4-inch pickets, 7-11 or 8 and 8 rise and run. Those are all based on the code of what you're building. Did that answer your question?
Yeah, that's helpful. I suppose that would be the, I get involved quite often with change of use assemblies, where it might be an industrial building and the owner wants to have a change of use for apartments and retail or mixed use. And the apartments, they're trying to figure out how to exit and that kind of thing. So it's kind of a little bit of a gray area, but I've always kind of taken the tack, if it's a change of use, it's kind of got to be considered like new construction. But I don't think that always has to be the case. So
No, not always. And in some cases, I've had people build their fire escape systems first on the wings before they even go in for a change of use. So you have, knowing what's coming, they build this fire escape system on the outside of a factory or a big box or whatever, and then they go in for change of use. So they add it as an additional means of egress to the building, and then when you redesign the building, you already have a certified means of egress outside that you count as your second means of egress while you submit plans to the city.
Interesting.
2 steps. Okay? So as you can see on this training tower, when I inspected this training tower, look at all the rust. With my hammer test, that fire escape was ready to collapse even when firemen were training on it. It shut down the day I inspected it. So believe me, everybody's violating fire escapes because it's the bastard child of egress. Nobody believes in it, but now it's reached the critical stage. It's injuring or killing people who actually are affected with direct use. But now it's injuring or killing people who have indirect use or passerbys. One quick question for all of you. Are you aware that a lot of fire escapes, especially on the West Coast, the only way to get to the standpipes is through the fire escape? And OSHA doesn't allow you to load test standpipes unless the fire escape is certified? The working platform must be certified while you're testing the standpipe. The standpipes are to be used by the firemen, and so in order to test the standpipes every year or every 3 years, whatever your code requires, you need to be on a certified fire escape in order to. So it's a catch-22, chicken or the egg. Who can certify first? So sometimes fire protection people are not allowed on a fire escape because it's not certified, and the building can't continue with its occupancy because the standpipe is not certified, hasn't been tested. Catch-22s. So rust jacking, this is during an initial inspection. You would never load test such a structure. Initial examination, you'll never load test such a structure. And believe me, you'll have people saying, I'll temporarily fix this and temporarily fix that, then load test the whole thing. And you can't. So the initial examination of a load test it's a pre-load test evaluation. That's why you charge little money. So as an example, if you charge $1,000 for a pre-load test evaluation, but you charge $3,000, $5,000, $8,000 for a technical repair report specifically telling the vendor everything that must be done. It includes 3 to 5 visits depending on the size and complexity. That's what a technical repair report. You're getting very well paid to verify the deconstruction and the reconstruction of an existing structure. Now, here's the other biggest problem that you have, the unknown behind the wall. And as you can see, a lot of people don't know that, who are laymen, but the architects and the structural engineers know this, that the fire escape is embedded into the masonry block wall or the masonry wall behind it, it goes through the veneer. But as you can see with masonry veneer block, there's usually a half-inch gap, water gets in there, and fire escape components usually rot out inside a building, and you'll never see it on the outside of the building unless there's some telltale signs such as these rust jacks, rust tears, dragon tears we call them, okay? So a lot of times, do you want to cause this much damage to the wall? Do you want to get in here and dig this open because you could be opening up a can of worms? Or is there an alternative method that you can use to basically connect this fire escape and let sleeping dogs lie behind there? Because obviously you can see the water problem on this is behind the building. It could be coming from the parapet wall. It's not coming from the outside because the outside, it's pretty good steel. But inside here, it's all rotting because it's being water fed from the interior between the veneer and the masonry block wall. So a lot of times what we recommend is that these get additional epoxy bolts, like a Hilti epoxy bolt, 8 to 12 inches deep. So a lot of times you would verify that the connection's in good order by making sure that there's no more water getting into it. If you can see that it's already spalled and blowing out the whole piece, you definitely got to dig it all out and take it all out and put a new member in. But in some cases, where the connection looks good visibly from the outside onto the veneer, and you don't want to go inside the wall to do all this verification, and you are concerned about load testing it by basically taking a angle clip 4 to 6 inches away from this T-bar, C-channel angle, and you put it a 3/4 inch or a 1 inch, the norm is 3/4 inch threaded rod, Hilti epoxy, into the wall, 8 to 12 inches deep, and then you make a mechanical fastener back to this original this original bracket into the building. You've basically nullified the need for a load test because you've basically negated the need for the load testing and the verification of your primary and original connection. Anybody have any comments on this very important part of the load testing? This is probably the worst part of it, the unknown that nobody knows how to figure out. Anybody want to add some comments to this? They agree, disagree, want to add a comment? Tough crowd. So this is, in the NFPA, other evidence of strength. We need to make the building department happy by showing them that we've negated the need to verify this connection, but yet we've secured this connection so it doesn't get any worse, and that the new connection is the Hilti threaded rod epoxied into the building at every connection, okay? That eliminates the load test in many cities and many states. The rebolting of every connection on a fire escape, that eliminates the load test. Again, with verification through a confidence test that there is no internal rust on every connection. There's a 25-point examination that you are stating on the pains of perjury that you have verified there's no internal rust in any of the connections, because if there is, you didn't repair that, you restored that connection. But if you change all the fasteners on a fire escape and you reconnect the fire escape back into the building using the Hilti epoxy bolts, there's no need for a load test. You've satisfied what's called other evidence of strength. You've satisfied an engineering analysis requirement for that city or for that state. Okay? As you can see here, this is the through bolt back into the building. Again, sometimes you have to open it up just to see what's in there, verification. And sometimes that's enough for an engineering analysis, because in some cases the entire building is wide open. You can see the outside, you can see the inside, and as long as there's no deterioration of the connection, here you are looking at a building that while they were dealing with the fire escape and the full renovation of the structure, they had a scaffolding company here, and those are second means of egress stairs, not construction stairs, which is different. Those are all 36-inch wide, 711 egress stairs that, should there be an emergency, all the vendors inside can get out safely. Okay, so that's what OSHA 1910 means when it comes to continuing with the project. There's a live load test. Now, gentlemen, this is a live load test sandbag test that I recorded just to help you understand the silliness and the awkwardness and the danger of load testing fire escapes, because sometimes the only way to place a bag on a fire escape is by standing on the very fire escape that you're load testing. So it's the chicken and the egg. Who's first, who's second, who's not supposed to be there. Some of these fire escapes you can't cherry pick and bring the load over. So let's take a look at the physical. It's a cascading. What you do is you bring all the sandbags to the very top, 50-pound sandbags, bring it to the very top, then start coming down. Now, I did this in Cambridge, Massachusetts. I purposely load tested this, spent an entire day with 7 men, and I did not charge. This was a Harvard University property. I didn't charge Harvard to do this load test. I just wanted to do a load test so that way I can prove and show people who are, wondering what is a physical live load test using sand. Well, here it is. This is what it looks like. So as you can see, that's one form of load testing. The next form of load testing, and that is when you can get the weight underneath the fire escape, whether it's sandbags, plates, water tanks, water barrels, or a physical truck. I put a 7,000-pound truck underneath the cantilever, and I started using a load cell. I started load testing 10 stories in California. And as you can see, it too has its risks. It too has its concerns. And as you can see, the cable has to run 10 stories. Got to take measurements before, during, and after. Half-hour to 1-hour intervals on a lot of the load testing, including the lateral load testing on the rails, 200 pounds. As you can see, you spend a lot of time. So let me open it up to any questions, any comments, any concerns that anybody's hearing or seeing so far. Guys, I can't be that great. Somebody must have a comment. Somebody must have a concern.
What constitutes a failure in a load test, the minimal failure?
A lot of times, deflection beyond. So an engineer will tell me that if you get a deflection on your measurements, your pre-load test measurements. So let's say I have 1,000 pounds I have to put on it. The load testing requirement in that California was I load test 400 pounds for 15 to 30 minutes, as per depending on what I was load testing. Then the remaining 60% was added, and I had to take measurements before, during, and after. And if there was a deflection of at least a 1/4 inch, then I was supposed to suspend the test and identify just what the concern is, whether the metal is deflecting, whether the bolt has given out. But a failure is some sort of deflection that is beyond the engineer's requirement, and that could be, anywhere from a quarter inch to pretty much the max. Because a lot of times, believe it or not, even though I was load testing 3,000 pounds, there wasn't much deflection that I saw. On the lateral load testing, I'd get some deflection. That's expected. But on a platform, I wasn't getting much deflection. Those diagonals were holding true. It's only once in a while that I get, if the diagonal had a pocket of cement that wasn't fully cemented, that I get a little bit of deflection, and then we quickly identified that the diagonal at the pocket going back into the cement, there was nothing there holding it. You know what I'm saying? Should you also load test it in a bolt that's an older bolt shears immediately? That's an immediate stop. Here's some of the the tags that they want in Seattle. Yes. Yeah. Again, you're echoing. So if you want to kill the mic. What Warren was asking is, what is some limited testing that can be also given by the engineer? So instead of a sandbag test, a water bag test, or water barrels down below, what other tests can be performed that are part of an engineering analysis and not truly a load test, but a partial load test or an integrated load test? So an engineer may have us do a pull test on the actual threaded rod that comes out of a building. You know, so we'll attach some sort of mechanism to that 3/4 round or 1-inch round threaded rod that comes out. We'll screw a nut onto it and start yanking on it, and the engineer will have us pull on it based on his calculation, do a pull test of 500 pounds, 750 pounds, whatever he deems is necessary. There's also a load test where he says, if you can't get to that nut, then I'd like you to concentrate a load on the nose of this bracket and pull down, do a pull test. So there's a pull-out test, there's a pull-down test, and I want you to do only 400 pounds on each individual bracket. I don't make that calculation. The individual engineer that we're working with will tell us what he's comfortable with as a partial load test if we can't get all the sandbags up there to put 1,000, 3,000 pounds on a particular platform. And a lot of times the fire escape is not fully loaded, so we don't bring 10, 20,000 pounds of sand to a fire escape. We would bring 2,000 to 3,000 pounds of sand, and we would load test bracket to bracket, and then stair bracket to stair bracket. So we'd load test things individually. So it could take all day just by moving the bags around and load testing different components. Sometimes we'll load test 3 brackets at the same time, and it's just a mathematical equation of how many pounds does that take, you know. The tags that you see here in front of you are typical of Seattle. Seattle wants 17 high, 19 inches wide. 17, it was either 11 by 17 or 11 by 19. I apologize. So it's 11 high, 17 or 19 inches wide. But the key is they want the yellow for fire escapes that has deficiencies, it's under repair. Red for fire escapes that are not safe for tenants or for firemen. And then white for fire escapes that are good and see you in 5 years' time. Now, the red one can be temporarily put on, and as soon as you do the emergency repairs, it can go to a yellow. So it's not common for a red one to go to a white one. It's common for a red one to reach yellow status, and then yellow status goes to white status upon inspection, testing. You know what I'm saying? So any questions so far on this particular part of the load testing statement? Now, this is again for Portland. Portland just put a tag on there now that just has the date of when it was inspected. So in your head, you know, counts forward 5 years. So this fire escape should not be examined till 2021. But what month? Is it the first month, the last month? So most tags do have a starting month also associated with that. And in Portland, one of the other issues that is very common, that not many people know, is that due to people breaking into buildings, they eliminated the last piece of stair to the ground. And so in some cases, this is a 10, 12, 16-foot drop. But they're waiting for the firemen to arrive to put the ladders here. So that is something that they allowed that is causing a concern that they need to go back and correct. And a lot of people don't realize, but primarily only in the Northwest, they have this ladder here, but not for the tenants. This is only for the firemen to get all the way up to the roof. This is very unique and specific only to the Northwest, Portland and Seattle. Okay, let's continue on to here. This is what a typical tag looks like in Seattle. That is 11 by 17 or 11 by 19, a white tag. 7 to 10 feet off the ground, permanently attached. And on it has to have the information of who inspected it, what's the address, and on the right side here is a typical 8.5 by 11 tag for the similar information. So you can have very large tags, or you can have standard size tags. We are currently working with a national supplier for tags to try to get the tags off to be standardized, both the white, the red, and the yellow. That's coming and being rolled out so that you can actually go online and order these tags through the National Firescape Association, and it'll come back with all the information already, printed on there, so it can't be falsified. Last question. Not last question, but wooden firescapes. A lot of people don't realize that all exterior steel and wooden stairs need to be examined. So it's not uncommon for us to get to a building and find wood firescapes that need to be examined and need to be certified and need to be load tested. And these were supposed to be built to 100 pounds per square foot. So if you get there and you find that the construction was not at 100 pounds per square foot, but yet it's the second means of egress, you have a pre-existing non-conforming issue that you must discuss with your city official. Go ahead, Warren. Warren, you want to chime in?
Just had a conversation with the Merchant Road in New York City. They are no longer allowing any wood structures or fire escapes.
Okay. What Warren just said there, you're going to kill your microphone because you're not coming through. That he had the conversation with the New York City, and he said that no longer they're allowing new fire escapes to be built of wood, but existing ones can be examined indefinitely, right?
If they are default or distressed condition, they're not being allowed to replace them.
Right. So again, that's again on a case-by-case, city-by-city, state-by-state basis. Some city officials will state what the code says. Since 1930, all it must be made of non-combustible. You know what I'm saying? So, but this is again, you can maintain indefinitely as of the date of its installation. I've had fire escapes made of 100% cement, and we were down in California. We were down in L.A. At the docks, and Alan and I got there, and there was 8 cement fire escapes on a cement structure. You know what I'm saying? And they needed to be inspected and load tested. They were all refurbished to avoid the load test. One of the key words that you're going to always use whenever you're dealing with something that's a little bit strange, something that's 50, 75, 100 years old. We are load testing, we are repairing, we are inspecting as of the date of its installation. So you can't make people take 36-inch staircases and, rails and make them 42. You can't make people with 6-inch bars on center, 4 inches on center. You can't take a 22-inch stair and make it a 36-inch stair. So everything that's out there is pre-existing non-conforming. They're allowed to maintain it indefinitely as of the date of its installation, unless you have things like change of use and some other things that could trigger a new requirement. And sometimes if the occupancy use goes higher, the fire escape must match. So, but it's not uncommon for the people to use the word grandfathered in, which really means lawfully non-conforming. So it's now up to the AHJ to agree with you that this fire escape that you just finished examining, signing, certifying is a pre-existing lawfully non-conforming structure and not required to be upgraded to the current code today because it's a pre-existing non-conforming structure. let me show you one of these things. We have these in New Jersey. Believe it or not, only in New Jersey, in certain areas of New Jersey, they took ladders, and instead of making them drop ladders, they made them flop out ladders. And what we did here is we basically showed what it's like if a little old lady had to grab that chain, or a child had to grab that chain, hold it out as best they could, but then it reaches a critical point where you have no choice but to let it go, and it smashes the barrel down below. So if anybody's walking below this thing, a fireman, a tenant, a dog, they let that thing go, it's going to crush somebody's skull. So every now and then you have pre-existing non-conforming, not lawfully conforming. It wasn't right the day they modified it. So if you have anything that you can prove will hurt or kill somebody, it can't be grandfathered in. So every time we find these ladders, we notify the owner and the city official that this has been modified, but unlawfully. It's not grandfathered in. Okay? Competence tests, again, there's tons of them out there. Which one you want to copy, it's up to you. But they all basically have the same 25 questions. Some of them have the annual checklist, which is a very simple form of the bigger version. But you know, your biggest concern is really what's inside the building. Everything outside the building is easily changed. You can change bolts all day long. The average life of a bolt is every 25 to 35 years is when you swap out bolts. So most fire escapes that are 75 years old have gone through at least 2, if not 3, full bolt swaps. Sadly, in some of these cases, every one of these fire escapes still has its original hardware. And that's the conclusion of the load test seminar. Open it up to some comments. If anybody has any comments, concerns, questions, agreements, disagreements.
No, it's all good, Cisco. I've been through this a number of times, but it's all refresh our memories. What's that?
So in your conversations with us, Alan, and you've spoken with many city officials, how comfortable are you every time you speak with them that you're coming from a position of education? Because a lot of times it's not that the city officials disagree with you, Alan, is that they don't even know this stuff.
Right. Yeah, I mean, we find that a lot. I mean, I've been doing this for a while now, so it's becoming second nature to me. But there's a lot of AHJs that need to be educated, and we try to do that as much as we can.
If you want, Alan, one of the things that not many people understand, and you can speak right to a fireman, is this. If a fireman using a ladder off of his truck, going up 20 feet, 30 feet, 40 feet, if in the use of that ladder it happens to get away from him and it hits the ground, it just falls from the building and it smashes the ground. You know what the tag policy is on that ladder?
Nope.
It has to be tagged out, inspected, and load tested, or replaced. They don't even bother testing ladders. Do you know what happens when they bring a 7-story fire ladder?
Nope.
If they are in the process of using it and they just happen to hit a tree with it, a pole, the side of the building inadvertently while they're swinging it around, that apparatus is actually tagged out, and they have to load test that immediately in order to bring it back into service. And until they do that, it's not in service. And there's a annual, I believe it's an annual or every 2 years, but I believe it's annual. They have to load test all their ladders, including their fire truck ladders, every year. So if you ever want to have a comparison with a city official, primarily a fireman, just say, tell me the rules about your fire escape ladder on your truck and the ones you pull off the trucks. And as you mentioned some of the requirements and how rigid they are, why wouldn't they have the same rigidity on a system that is hanging on a building for 50, 75, or 100 years that nobody's maintaining, and people are whacking it all the time. The buildings are shaking through earthquakes and whatever. So it's kind of a disconnect for them that they will jump up and down for their load testing of their ladders, but they're not jumping up and down on the actual fixed ladders that they have at every building for their use.
Yeah, it's true.
So some other questions. Thank you, Alan. If you can mute your anybody else wants to chime in, say something. You don't all have to be shy, but Warren, you want to say something?
Yeah, I want to add another point regarding the New York conversation with Rick Roche. The New York Fire Department, all 5 boroughs, use the fire escapes, even the ones that are 6 stories or less, every day to fight fires. That's how they run the hoses up the buildings on these fire escapes, which are currently not inspected, especially the ones 6 stories below. And even the ones 7 stories above, obviously being inspected with questionable results as per the one in Soho. So they're very, very concerned about this, and the program will be put in place, as all cities and states should have it in place for any equipment that's being used by their fire department.
So, as you mentioned there, the biggest concern in the city of New York City is that everything 6 stories and above was getting some form of eyeball, some form of inspection during their what's called envelope inspection. So as the buildings that are 6 stories and above were getting checked for bricks, parapets, flagpoles, fire escapes, primarily it was a building envelope inspection over a sidewalk. There wasn't really a checklist of any kind for the fire escape itself. And as proven in this last inspection a few months ago, the fire escape was certified 5 years prior, only to have pieces of it fall during another envelope inspection by a subsequent envelope inspection, local law 11 they call it. Now, that means only 7 stories and above are really getting inspected on a 5-year basis, but everything 6 stories and below has never been inspected and is not required to be inspected. Even the envelope didn't need to be inspected. So it's a big, huge problem right now in New York City because they're all trying to figure out what to do next, because obviously this fatality is going to open up some concerns about the pedestrians walking underneath these buildings. So with that, I'm going to be concluding this fire escape awareness with a primary focus on load testing, welding, internal rust jacking, confidence testing. Does anybody have any questions that they'd like to throw in last minute, or any agreements, disagreements? Seeing no last-minute questions, I thank everyone for attending the Fire Escape Awareness class regarding load testing nationwide, and we'll keep you aware of future classes that we're going to be holding. This class was recorded, so very soon we'll have it up online. We'll send you the link, and you're welcome to share it with all your friends, colleagues that may be wanting to hear a little bit more about fire escapes. Thank you very much.
Thank you very much.
If anybody has any further questions, please submit emails to Warren, and Warren and I will field with your questions directly on an individual call. Thank you so much for attending the class.
All right, thanks.
Yep.
Thank you.